go to 6.6 in your journal and get the definitions for exponential equations and logarithmic equations and copy them down. Then I want you to look at the core concepts below. So I want to look at both of these core concepts, the property of equality for exponential equations and the property of equality for log equations. So looking at the first one, we say if we have a positive number b to the x equals b to the y, if and only if x equals y. What that means is, look at the example. If I have 3 to the x and 3 to the 5th, that means that my x has to be 5. So for this, the note, we're going to say make bases the same. And another example of that might be if I have 25 equals, so here's another example, 5 to the x. Well, I can make 25 have the same base as 5 to the x, and I know that 25 is the same thing as 5 to what power? Good, 5 squared. So I can say that therefore x equals 2. Now if I want to go to the next property, the property of equality for logs, the note here, you'll see if I have log base b of x equals log base b of y, if and only if x equals y. It's the same idea, except we're going to say take the log or ln of both sides. So when we do an example here, you're going to see what I mean by taking log or ln of both sides. So now go to your notes packet and look at 6.6, example 1. For part A, we're going to make a common base. So I can say for part A that we're going to make same base. This is just a little note to myself. Whoa. And for part B, we're going to take ln of both sides. And I'm going to use ln instead of log for part B, but you could use log as well. So for part A, 100 to the x and 1 over 10 to the x minus 3, I know that my common base is going to be 10. So I would make 100 the same as 10 squared, then to the x, so 10 to the 2x. And then 1/10 is the same thing as 10 to the negative 1 power, and then to the x minus 3. I have to be careful here because when I multiply this, I have to distribute the negative 1 to both. So this is going to actually equal 10 to the negative x plus 3. And then from here, when my bases are the same, I can just set 2x equal to negative x plus 3. Set my exponents equal. So I add x over to get 3x equals 3. And what would x equal? Good, x should equal 1 because I divide both sides by 3. Okay, and cancel that out and get x equals 1. And then for part B, I have 2 to the x, I'll rewrite this, equals 7. And if I take the log of both sides, or ln, so ln of both sides, I can use my exponent rules and bring this x in front, so I get x ln 2 equals ln 7. And then if I divide both sides by ln 2, I can just put this all in my calculator. So in your calculator, you want to put ln 7 divided by ln 2. and that's going to be my final answer for x. And it comes out to be about 2.81 because it's 2.807. So I just rounded to 2 decimal places. And that's how we get x. We'll try the monitoring progress problems tomorrow, so make sure you bring everything with you to class.